Assalamualaikum warahmatullahi wabarakatuh. We would like to present about biochar application in constructed wetland for wastewater treatment, a critical review. My name is Nurunisa binti Dalim. So this is my group member, Nur Alia Shakina, Nur Atira, Siti Khadijah, Nurul Ankistina and Nur Izzati Sansabila.
Constructed wetlands are a cost-effective, sustainable way to restore contaminated aquatic ecosystem using physical, chemical, and biological processes. Substrate in CW is essential for wastewater treatment efficiency and ecological interaction. Biochar, within its wide surface area, porosity, cation exchange capacity, and sustainable. It's a sustainable substrate made of its own material. It is increase of the pollution removal, improve microbial variation, and its own cost-effective. This research analyzed biochar quality for its own of bioremediation, its interaction with the plant and microorganisms, and its own involvement in the removal of organic and inorganic pollutant, emerging contaminant and efficiency of its own cell. So biochar efficiency is determined on its feedstock, which is pyrolysis, condensation, are all the factors that impact of CW performance. I highlight biochar's feasibility in CW identifies research gap and advocate for more research into its long-term stability, so the pollutant-specific changes and integration with advanced technologies such as electrochemistry and oxidation for large-scale wastewater treatment.
For the introduction, CVS for wastewater treatment utilize natural processes to treat various wastewater types, including sewage, industrial effluents, and agricultural runoff. Second, substrate role. Traditional substrates like gravel and sand aid pollutant removal but have limitation in efficiency. Third, biochar benefits. Biochar enhance pollutant absorption, microbial activity, and system longevity. And number 4, efficiency challenges. Traditional substrates show moderate pollutant removal rates, highlighting the need for improvements. And lastly, future focus. Combining biochar with traditional substrates can optimize CWs for better wastewater treatments.
So for the material and method that we use this report is a Scopus database, which is we have to access articles, review book chapter, and conference paper that are related to our title, which is Biochar application in constructed wetland. And one of the topics was biochar and constructed wetland. After the data was collected, we have to make a descriptive statistic, including mean and standard deviation, because we want to determine the biochar mediated biomediation efficiency of contaminants such as total N and heavy metals in constructed wetland. And then, after bibliometry analysis, this data was collected from a relevant publication and has been categorized. And a summary of the 5 minimum numbers, namely minimum, Q1, median, Q3, and maximums, was obtained. So, for this report, we have to drawing a biochar application, which is we have to use AutoCAD. So, I will explain briefly about it. So, as we can see, the diagram have a inflow. So, at the inflow, water is contaminated water, which is it's so dirty, and it can come from stormwater, sewage industry, domestic sewage, and so on. The contaminated water can be purified because of biochar application, which is biochar can be a substrate because of biochar production, which is biochar production can make a fast or slow pyrolysis, and then it can have a gasification for the inflow. A biochar application in constructed wetland also can make a nutrient retention and availability, and then the plant can grow healthy. So after that, the outflow of water reuse treated water to the aquaculture, industrial reuse, beneficial services, and domestic users, because the water is clarified and clean.
Next, for result, firstly, mechanism involved in biochar lead pollutant biodegradation. Biochar enhances pollutant removal in constructed wetland through a combination of physical, chemical, and biological processes. Its structure, influenced by pyrolysis condition, provide a large surface area for pollutant absorption and support microbial colonization. Biochar aids in chemical interaction like ion exchange and degradation, promoting the removal of organic and metallic pollutants. It also boosts microbial activity for biodegradation and nutrient removal, such as nitrogen and phosphorus. Additionally, integrating biochar with electrochemical processes improve the overall treatment efficiency in constructed wetland, making it a promising tool for wastewater treatment.
Assalamualaikum. My name is Nurul Ankistina binti Ahmad Sabri, S66843. Next, biochar in constructor wetland for target pollutant bioremediation. Biochar enhances wastewater treatment in constructor wetland by effectively removing a wide range of contaminants. It removes nitrogen and phosphorus, heavy metal, organic pollutant, and emerging contaminants like paramedical and personal care products through absorption, ion exchange, and microbial degradation. Biochar also reduces antibiotic and antibiotic-resistant genes, support microbial growth, and temperature removal. Modification like sulfuric acid treatment is just its performance of. Assalamualaikum. My name is Nurul Ankistina binti Ahmad Sabri, S66.
Application in constructed wetland has demonstrated several notable findings in wastewater treatment. It significantly enhanced the removal of pollutants such as nitrogen, phosphorus, heavy metal, and organic compounds due to its high surface area, porosity, and strong absorption capabilities.